Hi folks, CodeTutor here and my name is Anil Deshpande. In the last couple of videos, we have gone through how to apply solid principles to Android application which has been built using MEVM architecture. We started updating the model, which basically contained room database and the repository, changed the view model, and then we were wondering what else we can do to make our application solid compliant. In this video, we will continue to refactor the view model and repositories even furthermore and try to craft them in such a way that they become more solid compliant. We are not yet done with repository and the view model. So let's go back and continue from where we had left off in the previous video. So now we have a iCountry repository, and the country repository implements iCountry repository. And in the iCountry repository, if you come down, it now uses FilterCriteria. FilterCriteria is basically the strategy design pattern that we implemented in the previous video, using which it just becomes easy to extend the various filter mechanisms later future in the code. And what it is nothing but a interface, and any new filter will have to implement the FilterCriteria interface. And then we came across the usage of this particular FilterCriteria in the composable. We have created this composable which is called as observe filter key changes, which is being used in the real UI based composable, that is country info scaffold hosts observe filter key changes. So if you think about it, you have a composable 1, and under that composable 1, you have composable 2. The advantage of this mechanism is the second composable basically holds the reference to the elements of the composable 1, and if anything changes here in the composable 1, we will immediately be reported about it in the composable 2. That is the advantage of this particular mechanism. And you can see that here, observe filter key changes, we are using the changes that are happening to the filter by key to basically trigger the filter by functionality, and that uses the filter by continent. This mechanism of using a non-UI composable inside a UI composable is called as state hoisting, and it is a pretty standard way of implementing reactive UI, which is nothing but what our composables are. So even though we might be able to implement it in a different way according to solid principles using the concept of, say for example, flows, we will take a call to use this kind of state hoisting mechanism in reactive programming because it just makes it very easy to manage our changes across the multiple UI elements. So sometimes you have to take a call that even though it might not be very proper object oriented principle based solid compliant code, but through another way, if you are able to implement it in a simpler manner, it's perfectly fine to do it. So we will continue to use this. So let's continue with this particular code. We will build on top of this. I think there is a problem here. The view model that we are using here is a concrete class. So instead of view model, we will use iCountry view model. Same is applicable here as well. And then coming down. Now, if you have a look at this particular code, we have written if-else statement here. This part of the code makes this open and close principle violation, that is OCP violation, because later point in time, if anybody says that we want to apply different way of filtering, then we will have to come and start fiddling with the code that we have written here in the observe filter key changes. We want to basically make sure that this code becomes pretty much easily configurable or manageable from outside. We don't have to come here and start fiddling with this particular code. So what we will do is we will rewrite this particular code using a kind of a factory design pattern. We will create a filter criteria factory, and then depending upon whether it is a particular kind of filter, we will have our own implementation of this filter criteria factory. Say for example, drive by side will implement this factory, and then continent filter will also implement this particular factory. And then we will create a factory provider which will supply me the kind of filter that I need depending upon the parameter that I pass. So this is a very classic factory pattern that we are going to implement to make this particular code little bit easily manageable. So let me create a interface. Let me create it under utils. Let me call it filter criteria factory interface, and that will have a function create filter criteria, and then I will create a continent filter factory, and this implements the filter criteria factory, and by that it also implements create filter criteria function. And then I will create drive side filter factory, and this will also implement the filter criteria factory, and this will return me filter by drive side filter, which is a implementation of filter criteria. And if you see here, I am returning a more abstract here. I am not returning filter by drive side. The return type is filter criteria, but filter by drive side is a extension of or implementation of filter criteria. So this basically already makes it substitutable and dependency inversion. So I am already making sure that whatever the code that I am writing now is solid compliant. Now what I will do is I will create a Kotlin object, filter criteria factory provider. Here I will simply maintain list of factories, and then I will write a function here, get factory and selected filter value, which is a string type, and then based on that I will return a filter criteria factory. Once again, it is an abstraction that I am using, and I will return based on the string that I have received here in the get factory. And now once we have implemented this factory provider, it is time to use it in the observe filter key changes. So now just observe what happens. I will get hold of the factory filter criteria factory provider dot get factory, and what will I pass? I will pass selected filter value, and then based on that I will get filter criteria. And how will I get the filter criteria? I will use factory dot create filter criteria and pass the filter key, and that basically means I can get rid of this code and then instead write filter criteria. If it is not null, then ViewModel dot filter countries, then pass the it, and now our code becomes much more easily manageable and solid compliant. Now later point in time, if anything changes, I don't have to come and change if else statements here. I will have to just provide the new implementation of these filter criteria factories, and that will take care of itself. And this is how you make your code OCP compliant, that is open for extension, closed for modification. So it's good that we have made these changes. So this makes our code much more simpler. Now let me go back to the model, that is country view model. I think we are not yet done with the repository. We forgot something very important in the repository. So let me go to the country repository, not the interface, the implementation, which implements the country repository. And if you come down here, that is line number 26, this part of the code, that is get country list. This is basically getting the country list from a utility function. And where is it getting from? It is getting it from a JSON file. We are making it mimic a API by introducing a delay here, okay? And it basically fetches it from a country's JSON file. There is a problem with this particular mechanism. First of all, we are stuck with this particular mechanism where we are fetching the countries from a local JSON file. What is that JSON file? In the resource.raw folder, and we are fetching it from here. And the main problem is, why is the repository doing the work of deciding where the list is coming from? So right now it might be coming from a JSON file, but later point in time we might say that this needs to come from purely the database, or we can even say that it needs to come from API. That we can't do it right now because we are left with using this particular utility function that we had implemented a long time back when we had started this particular code. So if you think about it, there are multiple violations here. The repository is trying to do more than one thing. That is a SRP, and then it is a OCP violation as well. That is a open and close principle violation, because this doesn't give me a flexibility to change the code later point in time. I am stuck with this particular thing, and if I want to modify this thing, then I have to keep coming here and make changes here. That is a OCP violation. And then there is no abstraction here. Everything is being managed through some kind of a concrete implementation. That is a problem. So how do we fix this particular issue? That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.